Okay, this is video number 3 of radicals. So this is part 3. Radicals, part 3. This should be the last part for the radicals lesson. So we learned about square roots. We learned about perfect square numbers. So now we're gonna get into cube roots. Okay, that is next. So that's our next little chunk in our notes. Cube roots. Okay. Cube roots. So let's think back a few weeks to when we talked about squaring things or cubing things. So if I were to say the phrase 2 cubed. 2 cubed. I'm hoping that this would come to mind. 2 cubed is 2 to the power of 3. 2 raised to the 3rd power, however you want to say it. So cubed means the exponent right here is 3. Now, what does that mean? 2 cubed? Well, that means 2 times 2 times 2. 2 times 2 is 4, times by 2 again. We get 8. Okay? So, we're going to make a statement out of this. If 2 cubed, which is this, equals 8, so if 2 cubed equals 8, then we're going to talk kind of about the opposite of this. Then the cube root. Now, cube root, you got to put that little baby 3 up there. 3 is in your index, okay? So if 2 cubed is 8, then if I take the cube root of 8, guess what I get? I get 2. And that's because 2 cubed is 8. Okay, so it's kind of like an opposite relationship there. 2 cubed is 8, then the cube root of 8 is 2. So let's look at some more little examples here. We're gonna take cubes of the first 5 numbers. So 1, 2, 3, 4, 5. And I want you to cube those. Okay, so pause the video if you haven't already and try and remember how to do that. You can use a calculator if you want to. Okay, 1 cubed, 1 times 1 times 1 is 1. 2 cubed, 8. 3 cubed, 3 times 3 again, 27. 4 cubed is 64. 5 cubed is 125. And we could keep going. 6 cubed, 7 cubed, 1 million cubed. Okay. So now let's kind of think of cube roots. So I'm gonna be looking at these numbers in orange here. Okay, so if 1 cubed is 1, then that means that the cube root, gotta put that little 3 up there, else it's a square root, okay? Then the cube root of 1 is 1. So we kind of get back to that base. Okay, if 2 cubed is 8, then the cube root of 8 is 2. I want you to try this out on your own. Pause the video. Do the cube roots of the next several numbers. Cube root of 27, 64, and 125. Cube root of 27 is 3, and that's because 3 cubed is 27. Cube root of 64 is 4, and that's because 4 cubed is 64. So cube root of 125 has got to be 5 then for that same reasoning. Okay, now I want you to try and think about this. Cube root of 343. So maybe you don't know. And I wouldn't know either unless I was a math teacher, but I am. So you could get a calculator or get your phone on, and you could test things out and go, well, I can try 6 cubed. 6 times 6 times 6. Okay, and if you remember, you all should have a little exponent button. It looks like probably something like this on your calculator, the little upward arrow. I could also type it in like that, 6 to the 3rd power, 216. All right, so maybe it's 7 cubed. Yes, it is. So the cube root of 343 is 7 because 7 times 7 times 7 is 343. Okay. So, looking at these numbers right here, 1, 8, 27, 64, 125, those are all perfect cube numbers. So I want you to kind of think back to the last few lessons. We had perfect square numbers, 1, 4, 9, 16. Notice those are different from our perfect cube numbers because squaring a number has a different effect than cubing a number. So we're going to list some perfect cubes next. Well, here's the first 5 in your list. Okay, so we got all the way up to 5 cubed. Now, you could just take your calculator and kind of figure out the next couple. 6 cubed was 216. 7 cubed was 343. 8 times 8 times 8, 512. 9 times 9 times 9, 729. And let's do one more. 10 to the 3rd power, 1000. Okay, so here are some perfect cubes. Now, are these the only perfect cubes, guys? No. Okay, there's a million bajillion perfect cube numbers. There's even fractions that are perfect cubes. Okay, so, but I want you to start thinking about a number that's not a perfect cube. So like 2 is not a perfect cube. 36 isn't a perfect cube. Okay, lots of numbers aren't perfect cubes because nothing cubed can be that number. Okay, well, next thing I want to kind of talk about is, in the last video we asked ourselves, can we take square roots of negatives? And we said, well, no, because if you square anything, if you square a positive, you get a positive. If you square a negative, you get a positive. So square roots of negatives aren't really possible at this stage in your math career, okay? But now we got to ask ourselves, can we take cube roots of negatives? So your next little section is going to say cube roots of negatives. So cube roots of negatives. All right, let's kind of think about that. Let's kind of do a list similar to this, but instead of having +1 as the base, let's make it -1. If I were to cube -1, it'd be -1 times -1 times -1. That equals -1. If you have 3 negatives, negative times negative, positive, but a positive times a negative ends you with a negative, okay? All right, What about negative 2 cubed? That's negative 2 times negative 2 times negative 2. It's going to be negative 8. Negative 3 cubed. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Now you should be kind of looking at these lists going, oh, 1, negative 1. 8, negative 8. 27, negative 27. So what's negative 4 cubed? Negative 64. Okay, and we could keep going if we needed to. Now, why we're doing this is for you to see that you actually you can take cube roots of negative values. Cube root of negative 1 happens to be negative 1. The cube root of negative 8, what would the cube root of negative 8 be? Well, it would be negative 2. Cube root of negative 27 is negative 3. And go ahead and try that one. Cube root of negative 64, negative 4. Okay, so it is possible to take cube roots of negative numbers. So why don't you try thinking about this one. Set up a cube root, and let's put negative 1,000 in the radicand. So something times itself 3 times is negative 1,000. Write it down if you know what it is. Cube root of negative 1,000 is negative 10 because negative 10 times negative 10 times negative 10 equals negative 1,000. If you don't believe me, use your calculator, but also it's kind of some mental math right here. Negative 10 times negative 10 is positive 100. Positive 100 times negative 10 is negative 1,000. Okay. Cube root of negative 343. If you know it, write it down. If you don't know it, maybe look right here. So the cube root of positive 343 is 7. What do you think the cube root of negative 343 is? It's negative 7, because negative 7 times negative 7 times negative 7 equals negative 343. Okay, so it is possible to take cube roots of negative values, which means that all of these you can change to negatives, and they are also perfect cubes. So if you really wanted to, you could kind of underneath this list write all the negatives. Okay. All right, and then we're going to finish up with a little bit of practice on cube roots. Okay, so let's kind of put some things together that we've been learning. So cube root, don't forget that little 3. Anytime you say cube root, you need that 3 there. Cube root of 125 plus the cube root of negative 8. Feel free to pause the video, try it out without listening, that's fine. So something cubed is 125, and that's going to be 5. Something cubed is negative 8, and that's a negative 2. So I'm going to add those two things together. 5 plus negative 2 is 3. Okay. Take the next one. Cube root of 200 times the cube root of 5. Oh, uh-oh. Cube root of 200. 200 was not on our perfect cubes list. And 5 was also not on our perfect cubes list. But I see this multiplication dot in here, and this kind of goes back to something we did with square roots. You can multiply the radicands. Radicands are the numbers under the radicals. You can multiply the radicands as long as they have the same root, and both of them have the third root, okay, or a cube root. So this is equivalent to the cube root of 200 times 5. Well, 200 times 5 is 1,000. And something cubed is 1,000. 1,000 is a perfect cube. So the cube root of 1,000, 10. Okay, let's do 2 more. We're going to take the cube root of a fraction. Don't freak out. 24 over 3. And then we're going to add that to the cube root of negative 1,000. Highly encourage you to pause the video. Try it out without me. Okay. 24 is not a perfect cube. 3 is not. So I'm going to divide first. 24 divided by 3 is 8. So that's the same thing as the cube root of 8. Cube root of negative 1,000. Well, 1,000 is on my perfect cube list, which means negative 1,000 is also in there. Cube root of negative 1,000 is negative 10. And what's the cube root of 8? 2. That's because 2 cubed is 8. So I have 2 plus negative 10, which is 8. Sorry, negative 8. 2 plus negative 10, definitely more negatives. And then last problem here. We have a negative 5, and it's right next to a cube root of 64. And then we're going to subtract the cube root of negative 64. Now 64 is kind of an awesome number because 64 is a perfect square and it's a perfect cube, and that doesn't happen very often, okay? So you need to be very careful. Cube root of 64 is 8. Sorry, square root of 64 is 8, but the cube root of 64 is 4. Okay, so right here I have negative 5 times 4. And then I'm going to subtract, and then what would be the cube root of negative 64? Well, that would be negative 4. So I multiply real quick. That makes negative 20. When you subtract a negative, what happens there? Changes to a positive. So negative 20 plus 4 gets us to negative 16. Okay, so you might be thinking that we're a little sidetracked from our exponent lesson, but all of this is to work up to fractional exponents. Okay, so our next video, we're gonna go back to exponents, all right? And all of this stuff that we've been doing the past 3 videos is totally needed. So I hope you're asking yourself, like, why are we doing this? What does this have to do with exponents? And you'll see that in the next video. See you later.